everyone for spending time to coming here and then listening to us talking about Kafka and everything. So I think I would like to take this chance to communicate with everyone. I won't be say like it's a one-dimension sharing. I would say I hope everyone can share your feedback, share your comment and suggestions for our session, and we exchange the ideas. So for myself, I'm a software engineer in ByteDance. I have working for around 10 years in big data and the distributed system. So for today, I'm more focusing on the Kafka and then how Kafka streams and the streaming processing in today's sharing session. So I think from my point of view, like what I want you guys to take is only one thing. What is streaming processing and how Kafka streams can fit into streaming processing, can solve the problems of streaming processing. So I want you guys, after this session, after this sharing, I want you guys have a model in your mind, what kind of key features and what is streaming processing looks like, and how Kafka stream can fit into these key features. So this is the objective of this sharing. By the way, I think everyone will have different opinion about this. Feel free to share your opinions. Okay. So here is our today's agenda. First one, I will do a quick warm up for the Kafka introduction, and then we'll go into the streaming processing, the key features of streaming processing. Next one, I will share Kafka stream, some key features and the pinpoint we have in my previous experience. If I have enough time, I will do a quick demo. But honestly, the demo is writing in Kafka data streams. I just port over from there, and I think you guys, everyone can do it yourself offline. And I just explain a little bit for the code, and then for how I run the Kafka stream application. Then I will share a little bit more about what's the industry doing when using Kafka, and how does industry really use Kafka and our OLAP engine to support the streaming analytics end to end. Okay, so and then I will let five minutes for the question. So for Kafka, I think this one is from Wiki. Kafka is a distributed system consists of servers and clients that communicate via a high performance TCP network protocol. So I highlight the distributed system. From the definition of distributed system is like the component of this system are distributed across the server, across the machine, physical machines, and then they can communicate together with an efficient protocol. So this one from the wiki. For the Kafka, I think this one is just for warm up to build a map in your mind. What is Kafka? From left side, there are a lot of producers. So you can think it's extendable, it's scalable. So there are a lot of you can create a lot of producers based on your requirement. Producer is like you are a producer, you send messages to Kafka, and then there is a consumer which organized by consumer group. And then for inside of consumer group, there are a lot of consumers which can pull the data from the Kafka. And inside of in the middle, the Kafka is a distributed system. That means there are a lot of machine or server or brokers in Kafka's terminology. That means across it in different places. And then inside of each broker, there are different partitions. So partitions means you can imagine like I have a big file. I split it into 3 parts. So partition 0 is the first part, second part, and the last part. So, and then all these partition, for each partition, it will have a replica. That means for tolerance, I send my partition, my block into other servers. And then in the end, if one of the servers shut down, I can still recover from and then copy the data from other partitions and then to guarantee the fault tolerance. So this is imagine about producer, Kafka, and the consumer. So from this point, you can see like I use three producers, 3 brokers, and 3 consumers. So this means you can extend in each in each independently to got a higher performance and a higher scalability. Okay, so for partitioner and for the partitioner is like when you produce your messages, you can customize how you are going to send where your message will be delivered to. So because it's a cluster, you are going to guarantee the high performance. The optimal ideal solution is you directly send your message into the server instead of let the middleman to distribute for you, right? So that means the partitioner, the high performance one, is directly sent to the partitioner, and when you consume your message, and you want it high performance as well as scalable. So that means you are going to like for one consumer, it's ideally to consume directly from that partition or from that broker without any middle process, which got a higher TCP performance. Okay, I think that's the concept of the Kafka. So I'm not sure any questions until now. Okay. Okay, I will. After why I want to introduce Kafka first is because there are some features which Kafka can fit for the streaming processing. So let's go back to the topic of streaming processing. This one we call it streaming is because previously we have another terminology, batch processing. So you can just imagine what is the streaming. It's more like you can process record by record. That means it's more like a responsive, another people give me a record, I process it. But for batch, it's like you can accelerate a batch of records and then process it. I think from this terminology, you can differentiate what is batch and what is streaming. And then there are a few key features for streaming processing. One is the time. So I think even for batch, I don't want to say like it's very specific for streaming. Even for batch, there is still the time semantics because you only care about yesterday's data. Yesterday is a time, right? So for streaming, why it's important is because when you calculate the data, what time you are referring to. From the event time or processing time, there are two terminology, maybe three terminologies in there. One is ingestion, one is processing, one is event time. But mostly in real cases, in my previous experience, we more care about the event time because this one is more linked to customers' real cases because the data it's being produced, being generated is the event time. That means this event generated time instead of the data arriving into your distributed system or it's when you are processing. So these are the difference. Another important thing is a time window. I think even for batch and streaming in your mind, you can think about there is still a time window concept. For batch, you can retry, you can rerun every time for yesterday's data, but yesterday is a window as well from 0 o'clock until middle night of current day, right? And also also monthly data. So that one is still a window. And also for the streaming, why this one is more important is because when you want to got a matrix, you have to understand like what's the business meaning of this matrix. When this matrix happen, how you link to how you can take actions. So this always, the business matrix always have a time meaning. That's why every time when we calculate our streaming metrics, we always add a window. Maybe there are three types of window. One is for company sliding and a session window. I don't want to share very details of what they are, but the key sense is like how they are grouped the data you are going to process. Just think about the way behind. This window is how to group this data. When you as a consumer, then how to group it and then for processing. So for company and sliding, it's like you set a window. It maybe can slide in it, but the window size and when it trigger is still you limited the record you are care about. And also for the session window, it's like the time between each window, how many, what's the limit between each window you are care about. It's still a way of your selecting the group of record you are going to process each time. And then another thing is for state and state store. So why this one is important is because when you are processing, you are continuously processing. For streaming is I continuously receiving the data instead of I receiving by a bulk of bulk. If I continuously receiving the data, I do the aggregation, I do the window join, I should have some state to keep it temporarily in somewhere or in some persistent storage. So this one will help you, like during some failure, you can recover from there. Because when streaming processing happen, it's gone. The data, when you didn't processing it, or when you're processing it, it's gone. But when you got failure, you have to replay it. But replay, you don't want to start from the original place again. You may pick up the last time you have finished and then to do it again. So that's the value of the state and the state store. State store is more like where I save my state. If you understand the concept, you will know like, oh, I should have some place to keep my state data. Whether it's in memory, it's in RocksDB, it's in HDFS, it doesn't matter, right? So it depends on which technology are you using, Flink, Spark, streaming, or everything, right? So the last one for streaming processing is checkpoint and a snapshot. I think they are the same thing. So which means you can imagine if the data keep coming, in sometimes you have to take a snapshot to let the engine, let the framework know like what's your last success processing, and then you can pick up from there. That success, maybe in Kafka it's committed, you commit or offset, but in Flink maybe you take a snapshot, take a checkpoint, or you take a save point. It doesn't matter about the concept. It's just a matter about why we need it. The reason because is we have to take the checkpoint and recover from last succeeded one instead of we start from the original one. So I think that's the key point why we need it. Okay, so and by the way, where we save this data is still doesn't matter, but in different technology, it's different. So like Kafka, they don't have a formal terminology of checkpoint, but in Flink, it have something like you can checkpoint your data into HDFS, and then you can recover from there. Okay, I hope any questions for this concept about the streaming. Okay, feel free to share if you have. Okay, so then let's go back to Kafka Stream. So you have a streaming requirement, how you are going to implement it. There are a huge amount of technologies here, so you want to make decision. So for here, I want to more share some of the key features which link to the streaming processing and help you to make decision. Kafka Stream is a lightweight streaming processing library. This word is a little bit different. Why? It's because it's a library. That means it depends on some heavy framework. It won't need to running in some like Flink cluster, Spark cluster, and then you can running as you can plug in into your application, and then just running there. So it's the meaning of library, and then there are a few features in there. If we go back to library, it means it's lightweight. That means you already have a microservice or any application running there. You just rely on a dependency for the library, and you start to consume from Kafka and do the processing and write into Kafka. So that's the typical usage. And it has a state store feature, which means during the processing, if your application fail, it still can recovery. This one match the previous concept of streaming processing. Especially when you have window join and aggregation, this is very important. You don't want to compute again from the last success point. For time and a time window, it supports event time, processing time, and also support different kinds of time windows. But I think the terminology may be different, like hoppy window, slightly window, tumbling window. I think this terminology may be different in different technology. It also have a exactly one support. This one is super important because when you are working on some critical business scenario, like in your business application, you want to calculate the number of GMV or anything instead of your traffic calculation. So this one you have to guarantee the number you will calculate is 100% correct. So this one, how it support is by using transaction and idempotent right. So for details, I think you guys can search or communicate offline. But I want to share some of the pinpoint from my perspective. I think there are maybe not the pinpoint from you guys. If you have some superpowered tools to help you. So first one is it coupled with Kafka. That means for other streaming processing framework, your source and your sink could be different. You don't need to bother, and it's not coupled with Kafka, but this one for Kafka stream, it's used for Kafka. So you have to get the data from Kafka and you write into Kafka. There is no shuffle. So I see this word, maybe you are not able to link to how does this matter? Because the reason is because if there is no shuffle, that means if you have different requirements about your key, especially your partition key, you have to sync into another topic. And then you do consuming and do calculating. But in the other framework, like Flink or Spark streaming, there is shuffle. That means for no matter how you organize your previous result, and then in the last stage, I can make it a reshuffle to and in the same job. So that means you can use same job to processing different dimensions of matrix. But in Kafka, you have to create a lot of topics in the middle to match this requirement. Especially we have some, for example, you have 3 dimensions. You want to see country, province, GMV. And also you want to see country GMV. This calculation logic will cost you have multiple Kafka topics by each requirement. But if you are using other frameworks, it will can be served by one job. Limited join. This one is more like when you want to join the topics, maybe it's a streaming table join or streaming join. You have to make these partitions in the same partitions, because as we know that we are not able to predict the number of partitions beforehand. So so that means highly chances like some of your tables have different partitions, especially when one of your tables are serving for different purposes. Like one is as a dimension for order, one is dimension for advertise. This one, the source have different dimensions. You have to create two topic or 2 tables. So this is a limitation. But why it has a limitation is because Kafka only guarantee partition level order. That means all your messages, all your data only be guaranteed order in partition level instead of topic level. Okay, and it has a higher barrels. That means we need to run a lot of code and then to finish your application and then to match your requirement and do the testing or everything. I think Conference may have some Kafka SQL, or this one will be benefit a lot. And you have to manually parallelism determination, which means how you are going to how many applications you are going to running in the same time. You have to manually carefully design it. It's not like you can configure parameter, it can auto scale. You have to think about how many partitions you have, and then how many instances of my application should be running, and then to fit to got the maximum throughput. Okay, so this one should be one of the pinpoint. Okay, is there any questions for this part? Yeah. It means it's a little bit complex to match your requirement. You need to write a lot of code instead of a very simple SQL query, and to match your requirement. Yeah. Okay. Any other questions?
You mentioned manual parallelism determination. That you mentioned as a pain point for stream.
Yeah.
But generally, for any kind of streaming processing, the parallelism has to be applied using manual option. Automation of parallelism can be done either in online data store or offline data store.
There are some platforms can support that.
So here the pain point part has been mentioned as manual parallelism determination. That is not only for Kafka. That is any stream.
Yeah. You are right. Yeah. Even, but a little bit slightly different is like Kafka, you think about more, but in other frameworks, you maybe think about a little bit lesser. So you have to set the parallelism for the operator, but that one you have to manually do it. But as I know, there are some frameworks that can automatically detect the throughput and then adjust the parallelism for you. But that one is an advanced topic. Anyone have interest, we can discuss offline. But thank you for your question. Okay, so
I have a question. So you named a lot of pain points here. So can you name some advantage of the Kafka streaming compared to Flinks?
I think the left one, right away.
I think this is standard features in other frameworks like Flinks.
No. Flink, you have to have a Flink cluster, right?
Yeah.
And it's still coupled with your application, right?
Okay.
Yeah.
So I think like the coupled with the Kafka is it's like a vendor lock-in that I cannot consume some data from other source. And is that right?
Yeah.
Okay.
But even though there are some limitations there, but I think based on your requirement, I think if some of the pain point may not be able to apply for your requirement. For example, you only want to enrich your topic with some, like for example, with some data in your store or in the table. You can directly use it because it's very easy to set up and very easy to verify. Otherwise, you have to learn what is a Flink, what is a Spark.
Okay.
Yeah, right. And also, if you have an application already, you just you want to add some logic inside, and you can just put in the logic into your application, and then you can very easily to verify your idea, your business idea or anything, and then to get the quick feedback.
Okay, thank you.
Okay, I think I may don't have enough time. I will share scenarios maybe quickly, and I won't be able to show your demo, but I can share how I may run the demo. You guys can run it offline. So for here is like the scenarios, typical scenarios I want to highlight is for join. In streaming cases, join, we need a lot of join, like join with dimension table, join with table, and a streaming join. And this one is more like we have a global store, which is the state store. I was mentioning, and then the source topic coming to your application. Enrich is your simple Java application. You can think like a Java class with a main function. Then you can call the data from global store, and then you can enrich. You can join with the data and to enrich other columns you are missing. Maybe you only have ID in the order. You want other details, you can enrich it. The second topic is like the top end, which this one is also very popular in streaming cases. You want to got the top end, maybe top, for example, top selling articles, top selling products, and then you want to know it in real time. So this one is more like you have a source topic, but your source topic are partition. So partition, and then you will have multiple application. And this one will, for each application, it only consumes 2 specific partitions. They are not cross. And then after that, you are write into another topic, and then you can dump, you can write into a DB after you after this one, you can write into DB, but just to take care that your key should be idempotent, and then the data writing into your DB should be overwriting continuously. So this is the scenarios. Typically, there are some other scenarios like real-time aggregation, or this one. I think it's similar. It's similar to this one. What I just want to share here is you can connect to some other database to enrich your data, and you can use this one to partition your applications to get a high throughput to consuming the data, consuming the source topic. Okay. Okay, I will skip the demo. So I will talk about what's the industry doing now in our real use cases. Even though Kafka is a very powerful streaming platform, and also especially for streaming messaging. So normally we have two pipelines. One is for the RDS SQL, and then another one is for the event, which is a customer's event on the website. And then for this one, for DB, we will have integration, and then sync the data into the ODS table, and then through few rounds of batch processing. Previously, it was running on Hive. Now, I think as data lake is coming, a lot of these jobs are running in there. And in the top, it's streaming processing, which is normally we use Kafka. Like Kafka will consuming the ODS topics, and then will processing, and then do the enrichment, and then put in there. I think the key point part, the key change part in recent years is we didn't do the aggregation in Kafka side. We sync the data into OLAP engine. That's why I'm coming to writing a database called ByteDance to supporting here. So all the data after your enrichment, we can put into the OLAP. And this one is a batch and a streaming unified engine. It can, one part can serve in your real-time query. One part you can batch plugin into the table, and then you can query continuous the query for the from the customer side. So there are a few cases like if in the batch here, if your data is wrong or your logic is wrong, you can do the update and delete in the batch pipeline, which better with previous version of Hive. You have to overwrite. In the streaming part, you don't need to spend a lot of resources on the aggregation and on the there, and you can just go into the detail topics, which is after enrich your columns, you build a fact table, and then you put into the OLAP engine, and you query based on your requirement. This one will definitely benefit your customer, your query portal, which is a BI portal. For example, you are using Tableau, you can have a lot of dimensions you are going to query. Previously, if you do the pre-computation, which means you already aggregated, it's hard to like serving different purpose. Otherwise, you have to build a huge amount of pipeline. But after this architecture, after using the new data OLAP engine, you have the flexibility to query based on different query and query the data within the seconds or many seconds. Yeah, I think that's the architecture currently we are using. Yeah. Okay. So, yeah. Thank you. Any question? Oh.
And
this one is a data model, data warehouse model. That means if you have a huge amount of data, in order to make your data reusable by others, you need to build a model here. This one is a traditional data warehouse modeling. ODS means replication with source data, and the D1D is a detail layer, which is the data warehouse details layer, and then it is just a factor table.
If you have more questions, we have another Q&A session right at the end. So I think now.
Thank you.
Thank you, Mingxing.